Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I'm Michael, founder of pgMustard, and this is my co-host Nikolay, founder of Postgres.ai. Hey Nikolay, what are we talking about today?
This week is my choice, and I choose replication. But this is just one word, but huge topic. Let's try to talk about replication, only trying to focus on areas which are interesting to backend developers and architects. So for people who create something, build something, and so on.
Yeah, exactly. Let's make sure, it'd be cool to cover the different options people have and the problems they're generally trying to solve when they're looking into this. We also had a couple of requests from listeners that cover this. So we've got the differences between replication, physical and logical, and also challenges on different managed services, especially RDS. So that'd be cool. And options like logical while shipping, while streaming. That came in by Twitter.
Two subtypes of physical, right?
Exactly.
Let's start from the problem. Why at all do we need replication? I see three areas where replication is needed, and two of them are major, and third is kind of controversial and maybe like. So first question where replication might be needed is high availability. For example, in cloud, our VM can be down anytime, so we don't want to have downtime, right? So we want to have almost zero downtime, or downtime less than 1 minute always.
Yeah, well, even if we self-host, the machine things can go wrong with one, and for it to fail over to a secondary is super helpful. I see primary and standby as the language in the docs.
Self-host, you mean you have some servers in data center. In this case, you have perfect opportunity to go a different route and go blame your provider of hardware and so on. So, in the case of clouds, this is less possible. So usually, and issues happen more often actually. Naturally, you can have very good hardware, so each server is running years. In cloud is also possible, but less often, right? So, and this is the first option anyway. Second is I have high CPU, or I have almost saturated disk I/O, or everything is out of cache or something. I have close to saturation resources which are close to saturation, so one machine is not enough. And in my opinion, this second option in clouds, it's also definitely possible, but in clouds it's easier to just increase resources switching to more powerful machine, right? Which is less convenient to do out of clouds. So this reason triggers more maybe sooner if you're not on cloud. But anyway, in cloud it also triggers, and at some point you want to offload reads to different server, and Postgres allows it. And the third option is using replication in addition or instead of backups. And usually it's a bad idea. First of all, for example, if you lose whole one node, it's about HA. It's not about disaster recovery and backups. But if, for example, someone deleted something, replication immediately propagated this change to all nodes. So, that's why we also always say replication is not for backups. But in Postgres, for physical replication, there is an option to have a special replica which will be delayed by several hours, for example, 4 hours. And if someone deleted something, you can use that replica and actually replay additional walls until the point right before deletion happened. right? And if you know this time, because sometimes it's not easy to find. And then you can manually restore the data which was deleted. It's called delayed replica approach, but I like it not so much because it's better to use branching or like, for example, database lab engine, and to have a specialized replica with snapshots every, like, for example, 2 or 4 hours or 1 hour, and we have a recipe to do the same point-in-time recovery starting from some snapshot. In this case, it's very fast, but always there is the option to restore from backups. You should have backups with point-in-time recovery with continuously archived walls, so you can restore from there. But if your database is, for example, 1 terabyte, you should be prepared to spend roughly 1 hour. If it's 10 terabyte, 10 hours, roughly, sometimes 5. So back to the main. So we will focus on two main use cases. We want to offload some workload to different server, or we want also to achieve very low downtime if something bad happens with some node. And of course, obviously, like interesting. Historically, in Postgres, there was some like idea this should be implemented outside of engine. Replication, I mean. Right. It only, as I remember, in 9.0, replication was implemented in core physical replication. Am I right?
Really? That recently?
9.0? Am I right about 9.0? Or it was 8 something? We should check. But it was not long ago, like in the middle of, for example, in 2005, we didn't have replication, and still there are ongoing discussions like we shouldn't have it in the engine, it should be outside. And there was a system called Slowney, which implemented logical replication actually based on triggers, and it was very difficult to, like, you need to allocate a single whole DBA to maintain it, so it was not easy to maintain. And then Skype implemented Londeste, also based on triggers, slightly better in terms of maintenance, and the good about those systems was that you can add additional logic easily, because you can specify which tables you want to take, and you can actually make transformations on the fly, like a lot of flexibility. But of course, since it's based on triggers, there is overhead. You write to a table, and trigger writes to an additional table, right? Then consumers propagate changes from that additional table. So kind of significant overhead. But you can replicate from one major Postgres version to another major Postgres version, great. But nobody guarantees that subscriber, so recipient node, will have the same data. Like there are many risks when you use this system. So it's not as reliable. And then, based on wall existed write-ahead log. So Postgres writes any change first to write-ahead log, and then and synchronize it with disks. Right. So it's guaranteed that write-ahead log has all physical instructions of all changes. So based on wall, the idea is wall is used when we replay Postgres after crash. Replace changes since last checkpoint. And the idea was, let's take this mechanism and have another node which will be always replaying these walls. And it will be constantly replaying them, and that's it. It won't be allowed for this node to write itself, always just to replay. So like constantly being in recovery mode. That's why function to check if it's primary node or replica node, standby node, it's called pg is in recovery. It's very confusing. Like each standby node, each replica, it's like a kind of in recovery constantly. But there is additional like recovery process for standby nodes after crash. It also can crash, right? So there is recovery, and then there are two types of recovery state, I would say. Like normal and not normal. So
It's a really good point, though, because I think some people come to this having had experience of other databases and wonder if there is a way of having multiple nodes that they can write to in Postgres, and that's not an option in vanilla Postgres. Whereas there's some kind of Postgres compatible database that do allow that. We live in a world of you have one primary that you can write to, and then you can have multiple replicas from that you can read from as well.
Right. For physical replication is based on wall, and it's just we are constantly in recovery, but accepting connections. Okay, we have physical standby. What we need to understand that it's everything. Unfortunately, Postgres wall, it's a single thing for whole Postgres server, so-called cluster and Postgres documentation. So we cannot take only one database, unfortunately. Although such projects exist, and maybe it will be implemented at some point. Other database systems support it, for example, SQL Server. So what we have here, we have a node which is constantly replaying walls. It means that everything is there, all tables, even bloat is there, which is good actually sometimes.
Yep.
And this is called physical replication. And you mentioned that in request there are two subtypes of physical replication based on wall shipping, and historically it was implemented first, and second, streaming. Why we have two? Because they're slightly different. Wall shipping is more I would say it's more reliable. And also you can ship walls from archive, from object store like S3. AWS S3, and even primary won't know about you. It's convenient. You can have a lot of replicas like that, but lag can be significant, some seconds already.
Okay, interesting.
Yeah, and wall files are 16 megs by default. As I remember, RDS increased them to 64, if I'm not mistaken, but to get that file, to store it, it takes some time. So that's why streaming replication was additionally implemented in an effort to minimize the lag, and also to get better control replication slots. Replication slots is just the idea that it should be visible that we have standby nodes, and we should be able to understand what are the lag there, and you can see even detailed lag there. So when you design some system, you can understand, okay, we will have standbys, they will be asynchronous by nature, so lags are possible, and we can also see from sitting on the primary what are the lags, and including phases of the lag, in transfer, or flushing to disk, or replaying, where, how lag is. We can zoom into lag and see it under closer. But standby nodes are asynchronous, but it's possible to make them synchronous as well. With obvious trade-off, if we say we need synchronous behavior, then our transaction at commit time will need to wait until this transaction confirmed to be committed on both nodes or on 3 nodes. It's very expensive in terms of writing transactions, right? But with funny trick, you can design your system that not every transaction will behave like that. You can have a node synchronous by nature, but then say this transaction is super important, so I want this transaction to behave as synchronous. It's just controlled via synchronous commit, right? So you can say I want this to be saved on multiple servers. This is a trick not everyone knows, right? So
yeah, I didn't know that. That's cool. Do you use that?
No, I actually see a lot of companies and people who use synchronous standby nodes, and also there is an option to say, okay, I have many standby nodes. I want at least one of them to receive the change. It's called quorum commit. You say how many nodes should receive it out of all existing nodes. It's also possible. There are many things which are now possible for physical replication, but somehow we live with asynchronous nodes, and lag are very small. We control them usually using slots, and later newest Postgres versions have protection there is I remember my ops people told me they are afraid of slots because if some node is down, slot is accumulating a lot big lag, and then you're out of disk on the primary. Now we have protection. I don't remember the parameter, but you can say not more than this number of gigabytes. Then this node will be considered as completely lost, and slot will be like not working anymore. But you're safe your free disk space on the primary. So like it's quite powerful. But if I'm a backend developer, I need to understand that nature is by default is asynchronous. If I want synchronous, I want to be very careful. I want to understand all network latencies because network is involved now, right? And of course, if I use standbys only for H-shape, high availability, it matters less. And I, of course, should use Patroni or something. Patroni is most popular auto failover. By the way, same idea, it should not be in core. That's why it's outside. Here, like in replication, the idea, let's have it in core won. For auto failover, not yet. It's still outside. In my opinion, everything should be in core, but there are many things, obviously, that prevent it from happening. So if you have HA, you don't put load there. You have a lot of money, why not? Then you don't deal with, like, you just need to control the lag in terms of the health of this node, right? And primary is down, and lag is known to be small. Okay, data loss is small. If it exceeds, for example, in Patroni, we control it. We can set allowed lag for failover event. If it exceeds, if Patroni knows that the lag is too high, failover won't happen because we don't want data loss. So we can prioritize. We have trade-off here. What to do? Failover and have a lower downtime, or we want to save all our data. We don't want data loss. So we probably have. It's better to have downtime, but try to fix primary and save data. There is trade-off here.
If people want to like read up more about this kind of thing, I've seen people using the, like, if your boss is demanding zero data loss and instant failover, I've seen the letters, the acronyms RPO and RTO, and people have written a lot of useful guides around.
Well, RPO, RTO is good to understand, but it's more like ops terms.
Exactly.
How to define as SLO, SLA, RPO, RTO. I can explain it. It will take a few minutes, but I think it's not that interesting. Like, returning to these subtypes, we have wall shipping and we have streaming. Of course, streaming should be preferred if you want a smaller lag on your nodes, and especially if you want to offload reads, selects, or with recursive or non-recursive CTEs. You want to offload it, so to reduce load, or very often it's CPU load, sometimes it's disk I/O. You want to offload it to replicas, standby servers. You probably would prefer streaming and with replication slots for better observability. But the trick everyone implements, everyone who deals with such system, is okay. Sometimes we have lag, few seconds. What if, and for example, we have a page or a mobile app, and the user created something, and then immediately tries to search, trying to check the result. If user is very fast, and our standby node has some lag, user might see no new items in the result set. Where is my post or comment or something? In this case, every experienced backend developer implements the pattern, how to say, like sticky reads. I named it like this, sticky reads. So you say, okay, in my session or this user or something, you need to identify somehow your user. If you have sessions, it's session. If you have like REST API, no context on server, so maybe you need somehow to identify like customer ID or user ID. So you say, okay, some recent data change happened, and we mark this user as like recently changed database. Some flag in cache, in some cache, like memcache, Redis, anything. And in this case, you need to teach your backend to work only with primary for some period of time. So stick all reads to the primary. That's why I call it sticky reads or sticky selects. And the funny thing that a couple of years ago, Ruby on Rails, they implemented it. So it's there, and you just can use it. That's it. I think every framework should think about it, because they should think about scaling and performance issues. Because if you don't scale, users will be suffering in terms of performance. The closer you to saturation, for example, of CPU, the bigger problems can happen. So
I also sometimes
good.
Yeah, that sounds cool. The other thing I see people using replicas for in terms of reads are kind of read-only parts of the app. So like like dashboards or their own internal analytics, that kind of thing. What risks are there?
Postgres doesn't allow to do it without consequences. You have two options and both are bad. You just need to choose which is less bad in your case. First option, you have regular standby, which means host standby feedback is off. Host standby feedback signals to the primary the state of our standby. It's controlled on standby, on each standby, you can define it. And it says, okay, if it's off, I don't care. Like primary shouldn't know about where I am. But this means that any transaction that lasts longer, and all analytical queries tend to last longer, right? They will pause replication. And there are parameters for streaming and for wall shipping separately, which define maximum duration, because after which we can say, okay, it's enough. And we cancel transaction in favor to replay new changes from wall. Streaming or wall shipped, doesn't matter. This is not good because it makes your node like single user, because other users, like for example, one user is using, okay, I'm using it. First danger is that at some point the transaction can, like my read-only select can be cancelled. It's one can, but I can adjust this parameter and allow like a couple of hours. But other users coming to this server observe huge lag. That's why I say like virtually this is a single user node. Like you're alone there. Like others will suffer. So it's not convenient. That's why in this case there is another option which is also bad. It's called host standby feedback being on. We turn it on, and standby reports to the primary about xmin horizon. Like we have transaction IDs. And we have many transactions happening at the same time, like constantly, because it's multi-user system, right? And there is a vacuum which should clean dead tuples, which already dead for all transactions. But how to define for which, like all? To define all, here we need to understand which is the oldest transaction still ongoing. And this is called like xmin horizon. Xmin is because I remember you can select xmin from any table. There is always such column there. Our listeners who listened first episodes know. I like this, like hidden columns in Postgres. Xmin, xmax, ctid. So xmin is like birth date in terms of transaction ID. You can see when each tuple, physical row version, was created in which transaction. So we have multiple transactions, and the oldest one is our xmin horizon. And this is reported to primary. So primary auto-vacuum, all auto-vacuum workers on primary respect this and don't delete the tuples because they are considered still needed on some replicas. And imagine if you do it, you run some query on some node with host and by feedback turned on for many hours. It will lead to auto-vacuum unable to delete the tuples in all tables on the primary, all tables. It's like cluster-wide problem, cluster-wide. So we will eventually accumulate bloat. Later, transaction finished, auto vacuum deleted, and we have gaps. Gaps is bloat. Bloat should be distinguished from dead tuples. But dead tuples, accumulation of large volumes of them lead to bloat. And that's not good, affecting both table and indexes health. So constant back feedback on is bad, off is bad. Choose what you prefer. So I prefer, my idea is two other options. Both are good, but both are difficult to implement. First is don't use Postgres for analytical queries. Use logical decoding, logical replication to other systems like ClickHouse, Snowflake, anything. This is one. Second, but of course, it means like it's easy to say, but it's a lot of new expertise required and a lot of maintenance efforts. Of course, it's easier to create a physical standby and work from there. Second option is to have, again, branching or database lab engine and provisions clone or like branch. And new one just released branching last week, by the way. I'm super excited. This should be everywhere. Like, branching is super powerful. And I'm most excited about capabilities for development environments, for like non-production environments. But for production environments, it's also good. Like you have specialized replica, and when you provision a branched or cloned Postgres, it doesn't report to a primary at all. You can do like you have frozen state, of course. You're not receiving fresh changes, but you can do whatever you want. Like you're already detached from anyone, so you cannot be a problem for others. It's good. Well, of course, you can have logical replication. It doesn't report about xmin horizon to the primary, but it reports about it learns about system catalog changes. So if some DDL is happening, there will be a problem, which is a problem in general in logical. So the easy options are both bad. Difficult options are both good, right? But you need additional, you need additional tools for it. So that probably covers physical. Basically, just use streaming. It's good, reliable. You use wall ship replicas for standby nodes for cases when you have, like, for example, you want to provision and keep it up to date. Some environment where you do experiments, for example, like it can be based on wall shipping from archive. I prefer to touch the primary less often. And that's it. So physical is reliable, battle proven, everywhere, it's working, it's good.
How about logical?
Yeah, logical is good also, but it has a lot of limitations. First of all, logical can be used in old-fashioned way. Longest is still a tool to consider, based on triggers. Or it can be used, what we have, logical decoding and replication in Postgres. First of all, like for developers, you should understand that logical is based on basically on WAL as well. On WAL is recording tuple changes, like this is new tuple, this is new whole page that changed, and so on. Very low level changes. And logical is based on that. So it's not purely logical. It's like logical derived from physical, right? And this leads to many, many issues, actually. So many issues. But biggest issues with logical that it lacks some things, but which currently are under development. For example, DDL or replication of sequences. There is ongoing work, a lot of work, and hackers which improves it and solves these problems. So I'm quite positive that Postgres 16 or 17 will be much better in terms of logical. And recent Postgres versions 14 and 15, they also have improvements. On Postgres TV, we had guest Amit Kapila, who described logical replication improvements. But logical in general is needed when your destination should differ from the source. In logical replication terminology, they call the publisher and the subscriber. So like primary standby terms converted to publisher subscriber here. So for example, you want different major version, right?
So if we're doing an upgrade.
Or you want not whole database. For example, you want only a couple of tables. Or it's different database system at all, like ClickHouse. It's also possible based on logical decoding. Logical decoding idea is quite easy. Like let's have logical replication slot, and it will like stream our changes wall records, and we will consume wall records and decide what to do with them. Either ignore or somehow process and allow to consume. So there are plugins, so-called, which define this logic on the publisher. And the problem, one of the biggest problems with logical for me, but it looks like practically it's not that big. So it's always parsing everything. So like you cannot. It's both performance and scalability problem. It can lead to lags if you have complex records involved, like a lot of columns involved and so on. And also if you add additional stream and you want to say, okay, these tables will be there and those tables will be here, like divide and conquer. You won't conquer because consumption of CPU of wall sender on the publisher side will be this, like if it was 100% CPU of one core, now you will have two cores both consuming 100%. It's quite a problem, but I see that like it hits only at under very heavy load. Not like you should go before you probably hit the problem on the recipient side, on the subscriber. For example, if you miss some index and want to replay changes, right? And also splitting to multiple streams makes more sense here because definitely you can have multiple wall receivers and backends replaying changes on the recipient side, on the subscriber. So I also, for those who design and want to think about how to use logical, I wanted to highlight about one interesting point. We can distinguish two big areas of use cases. First is when we need all tables in Postgres. It can be different major version of Postgres, but still we need all of them. And second, everything else, like we need only partially all our database or it's not Postgres at all. So in the first case, I forgot to mention how we need to start with logical. First, we need to take a copy of database, maybe partially. And then second phase, we stream changes. It's called CDC, change data capture. So there are two phases, initialization and already working state. And the great news, which is not covered in documentation, that you can switch from physical to logical very easily. So you just have physical standby, and then you create replication slot, logical replication slot on the primary. It will provide you LSN while it post. So this is a point when it was created, and we know that it's like the state is at this LSN. LSN it's like log sequence number. It's the sequentially increasing number in the wall. And then you can say recovery target LSN to reach the same LSN on the standby, right? And then you just switch to logical from physical replication, and that's it. So it will take a few seconds only. So you can have 10 terabyte database and provision logical in a couple, like from physical. Physical is easy, like it's already very well known how to do it. But if you want whole database, you can do this trick, and super cool to provision logical, and this opens the path to various experiments. For example, if you want to use logical for various migrations to different Postgres major version, or something like fight with bloat, I don't know, like change operational system, something like that.
That sounds super interesting for major version upgrades. So physical replication, then could we do an upgrade? Like then we can can we do the PG upgrade and then turn on logical replication to catch up?
Exactly. So you do this trick, and from physical, you convert physical node to logical node, and then you can stop it, upgrade it. During this time, the primary will accumulate changes in the slot. So once you're up again, you will consume and catch up. That's it.
Very cool.
Yeah. Super. So I don't know why people don't use it often. I would say this is secret of secret of Polychanel, right? Like very well known secret actually. Like many people know it, but it's somehow it's not in maybe it should be covered in documentation actually. But documentation in general lacks how-to parts. It's very occasional to see how-to parts in documentation in current form. So that being said, documentation is awesome, definitely. So, and if you need part of it, of course, it won't work. You can do it. For example, I want half of database. I do this trick, and then I will drop half of database. It can work, but in other cases, it won't.
That's awesome. I was wondering about two last things, depending on which one you wanted to cover. Either go into a bit more detail on any of the issues on the logical replication side, or potentially more interesting, one of the questions included any specifics for managed service providers. So like any limitations to be aware of in the popular ones like RDS, Google Cloud.
There are limitations everywhere, of course. How many nodes you can have. For example, many projects prefer having like 10 or 15 physical standbys and offload a lot of reads there. It's constant work for backend developers to find more queries that transactions that can be offloaded. But in general, as I remember, on RDS, originally, they distinguished two types of standbys. And first one was regular Postgres standby, and it was supported reads. And second was a checkbox multi-AZ, multi-availability zone. It was a hidden standby based not on Postgres replication. It was before recent changes. And it was not visible, you couldn't use it, so it's like just for HA. Now, as I know, they support, they changed it. As I know, like I haven't looked recently, but I saw in the news that now for this HA replica, read queries are also supported, which is good. So, like in ideal world, of course, we should have HA replica and others replica. But some people think we should have at least 3 nodes and don't care about which like symmetric schema when all replicas can be used for failover and all replicas can receive reads. I actually prefer this schema, symmetric, because if you allocate specific node for HA, well, caches problem, you need to warm up, right? For read queries, it's warm up automatically if it's receiving reads. So it's like kind of things to think about. Like I prefer this approach. Patroni actually is good for it as well. By the way, in Patroni, there is a problem with logical slots. If physical failover happened, you don't have slots.
Interesting.
And that's bad. And also logical, unlike physical can be cascaded. You can create interesting architectures. But for logical, it's always from primary, unfortunately, from physical primary. And there are many discussions how to enable logical replication from physical standbys. It would be great to have. But risks are shifted to standbys. It's much better. But unfortunately, it's not yet implemented. So if you have physical failover, you lose slots. But there is some recipe and Patroni implemented, and there is a talk from Kukushkin, which is Mr. Patroni. You can listen to. There are many interesting details there, and actually on Postgres TV, Alexander also presented this talk. Many interesting details. So it's like how to avoid full initialization for logical replicas. But for upgrades, we don't care about it because our replicas should live like some hours or a couple of days, right?
Yeah. So temporarily.
So we don't care about it. So there are many different use cases, a lot of them. And, yeah.
Awesome. Was there anything else you wanted to cover?
There are many things to cover. For example, physical standby behavior may be very different from primary. For example, if you have subtransactions, you might want to check my article about it and the disaster GitLab had. They also blog posted about it, a very good article. And it was quite difficult to troubleshoot. So the idea that we have the same everything, well, yes, we have the same everything, but there are small details that can differ. And if you have subtransactions and you should be prepared for growth, definitely worth checking that post, because physical standby can be different behavior, can have different behavior. Yeah, that's.
I'll definitely include it. Are we allowed to give a spoiler as to the main takeaway of that?
Yeah. So in general, summary is physical replication is very, very reliable in Postgres. Logical has issues, but people also use it. There are also derived products like AWS has DMS, GCP, Google also provides something in this area to migrate Postgres to Postgres, different versions, or from different database systems to Postgres. And also usually cloud providers provide logical replication connection, but no physical. It's worth keeping in mind. So you can migrate out of them only using logical. So logical it should be an arsenal, definitely, for various kinds of tasks. And there are products like, I would mention a couple of them, Click, former Attunity, maybe I'm pronouncing it wrong. They have issues with duplicates. They implement it wrong. I communicated with them many times. They just don't understand and don't bother to understand me. Because they create slot at SQL level, so they cannot synchronize it properly. So if a recipient database like Snowflake don't have unique keys, you will have duplicates if you need to when switching from initialization to CDC part. Or there's also a newer company called Fivetran. This is quite good. It's a commercial company, also works on top of logical decoding and supports a lot of things, and it's very like SaaS cloud oriented. But and I think pricing is also good, but it's worth considering if you want to save time. Right.
Yep. And last thing on the cloud providers is that they do often have that just like a checkbox where you can turn on high availability, right? So it's you don't need the physical replication for that if you use their own service, but normally costs double, just as if you were paying for a replica, right?
Right. But as I said, this is about RDS. Checkbox doubled for price for primary, and you couldn't use for reads, but they changed it recently. Worth checking. There are recent changes, so you can have the checkbox and still use every day this node for reads.
Interesting.
So
Cloud SQL is similar, I think, in that you can just turn it on, but I'm not sure about being able to use it for reads.
Right. Okay. Good.
Nice one. Thank you so much, Nikolay. That was awesome. Thanks for the suggestions for people that sent those in, and thanks everyone for listening.
Thank you, Michael. See you next time. Bye.
See you. Bye.